Welcome viewers. Myself Amir Sohel from Swami Vivekananda Institute of Science and Technology, Department of Civil Engineering. Now, today's our topics of discussion is about column. You know, name column where it is used whenever you go to your home. Always you will find a column supporting your rooftop. Okay, the column is essential thing, column is an essential part, or it is very evident that it is a part of modern civilization. So let us discuss about the column. So in this, that is, there is the content. You will learn about start, column, difference between column and start, failure of column or start, what is long column, short column, and about buckling load. There is a terms that is column end condition or effective length. It is the most important terms here used to evaluate the important parameters which is actually uh, define the column serviceability or column uh, bearing capacity, whatever you think. It will depend upon certain parameters, and column end condition and effective length are one of these. And second important terms we're going to discuss about, that is Euler's formula. You heard the name Euler's. We'll discuss it later. Some assumptions behind this formula formation and the limitation. Okay, let's move. So what is start? The question is what is start and what is column. Let let us pick the first term, start. A structural member subjected to axial compressive force is called strut. Strut may be vertical, horizontal, inclined. Mind it, strut may be vertical, horizontal, inclined. Okay, vertical, inclined, and pure vertical. Their orientation may be vertical or horizontal, inclined, whatever it is. The cross-sectional dimension of strut are small. Normally, struts carry smaller compressive load. All right. Strata used in roof truss, bridge truss. So you heard the term strut truss. It is used. It is widely used in India, and you will find truss member in your platform actually. A strut is a structural component designed to resist longitudinal compression. Okay. Next. So here is the a picture of a bridge which is consist of truss, and where you can find the strut member. It may be vertical, it may be horizontal, it may be inclined. There it is. These are the strut, and they can be arranged in any orientation. Okay, and here you can see the axial forces. This is compression. It may be in tension also, depending upon the load carrying mechanism. It may be compression, it may be tension. Okay, so now what is column? Is there any difference between column and stack? Yes, there are some certain different terms used in column or certain different terms used in start. Column are uh, directly related to civil engineering, and stars are related to all branches like mechanical, aerospace, and so on. So when start become vertical, then it will call column. Why? The cross-sectional dimension of the column is large. Columns carry heavy compressive loads, okay, because of this cross-sectional dimension enlargement. Columns are used in concrete and steel building. Columns may be designed to resist lateral forces. Okay, lateral forces means horizontal forces. Columns are frequently used to support beams or arches on which upper part of walls and ceiling rest. Next, here we can see some different type of columns. These are the reinforcement arrangement when you are planning to cast a column, and this is the end result when the column uh, is ready to. This image is used when we are calculating the loads. That means with the reference of this image, you can draw the Peabody diagram. There are some certain types of columns, but we are not dealing with types, namely Doric columns, Ionic columns. Okay, this type of columns you can see in various places, or whenever you watch some movies, you can find this type of column. Next, so there are some basic difference in column in between column and star. So vertical compression member is the column. Vertical compression member of a structural system is column. Compression member in any orientation with framework in your start. Application where you can find it in civil engineers, uh, primarily in beams, slab and piers. And for start, you can find it in mechanical, aerospace and truss system. Okay. What will be the load direction? Load direction actually column bears the load in axial mode, and start may be vertical, horizontal or inclined. Design focus strictly vertical. A column must have to be vertical, uh, maintain the verticality. Axial stiffness and compressive strength varied slenderness. We will discuss the slenderness terms later. Let's move to the next slide. So failure of column. There is some picture given here where you can see how a column is failed due to excessive loading. So when column take place, this type of failure take place due to some following reason. Direct compressive stress may be a reason, okay, and buckling stress. Buckling, when a vertical column is subjected to eccentric or concentric or eccentric loading, it will bear the loading, and if it is failed to bear, then it will show some deformation like this. Oftenly we know these terms as bending, but for column we will call this bending as buckling. Combine of direct compressive and buckling stress, the mode of failure of column depends upon their length. Okay, if the column is higher, the chances of failure is high. So depending upon that, column are divided into two terms, two types. One is long column and second one is short column. So following these terms, we can establish some important parameters. We will discuss it from the next slide.